Math. It shapes the world we know today. But how was it used to shape the world in the ancient times? Today, we're going to be learning how the ancient Mayan and Aztecs communicated their mathematical ideas and understanding the similarities and differences they share. Before we can do so, we need a little background history of who they were. Who were the Mayans? The Mayans were a group of indigenous people of Mesoamerica that originated the Maya civilization in the Yucatan around 2600 BC. Today, this area is southern Mexico, Guatemala, northern Belize, and western Honduras. The term Maya comes from the ancient Yucatan city of Mayapan, the capital of the last Mayan kingdom. By 250 and 950 CE, also known as the Classic Maya period, the ancient Mayans were at their peak power. It was in this period that the Mayans began developing the science of astronomy, calendar systems, hieroglyphic writings, ceremonial architectures, and mathematics. However, from the late 18th century to the end of the 19th century, great Mayan cities were abandoned, which were later repopulated by a new tribe in the region, the Toltecs. The reasons for the collapse are still unknown and remain a large mystery. In 1524, Quiche Maya were defeated at the Battle of Yucatán, which ended the Great Civilization. Who were the Aztecs? The Aztecs, who referred themselves as the Mexica, were pre-Columbian Mesoamerican people that spoke Nahuatl and existed in central Mexico for the 14th century to the 16th century. The term Aztec was derived from the word Azteca, which means people from Aztlan, believed to be a place in northern Mexico where the semi-nomadic Mexico had originated. The capital city of the Aztec Empire was Tenochtitlan and was first established in 1325 in the Valley of Mexico. Tenochtitlan was built on an island in a Mexican lake called Lake Texcoco, and the Aztecs gradually conquered the rest of the area. In 1521, the Aztec Empire was overthrown by Spanish invaders, bringing an end to Mesoamerica's last great native civilization. Now that we have a better understanding of who they were, let's see how they used math in the ancient times. Mayan numeral system. The Mayan numeral system used a vigesimal base 20 notation in which each position is a power of 20. The ancient Maya only needed 3 symbols to express any quantity. These symbols are a dot, which represents 1, a bar, which represents 5, and a shell, which represents 0. Every 5 dots is equal to 1 bar, and only 19 items can be in the ones place of a base 20 system. Having a symbol for 0 is the most important aspect of the Mayans' mathematical system because it acts as a place value. Without it, there would be no way to distinguish between numbers such as 45 and 405. Rather than writing their numbers from left to right as we do, the Maya wrote their numbers vertically from top to bottom. Let's understand how to write the number 453 using the Mayan numeral system. In our usual base 10 system, we would expand the number using powers of 10 by writing 4 times 10 to the second power, plus 5 times 10 to the first power, plus 3 times 10 to the 0th power. For the base 20 system, we write the expanded notation using powers of 20. In doing so, we get 1 times 20 to the second power, plus 2 times 20 to the first power, plus 13 times 20 to the 0th power. Looks can be deceiving, but after simplifying the equation, we get the same number. Now let's translate this by using the Mayan numeral symbols. We first draw a vertical rectangle and divide them into squares for the place values. Take the first numbers from multiplying powers of 20 and translate them into Mayan numeral symbols. Then place them in the correct place value box. And there we have it, the number 453 in Mayan numeral notation. Aztec numeral system. The Aztec numeral system also used the vigesimal base 20 notation and follows the same additive concept. The ancient Aztecs has many symbols to express different quantities. These symbols are a dot, which represents 1, a bar, which represents 5, a diamond, which represents 10, a flag banner, which represents 20, different feathers, which represents hundreds, and an incense bag pouch, which represents 8,000. Though there are many symbols to represent numbers, there is no symbol that represented 0. Because of this, the Aztecs had no place value holders for the symbols. Instead, they would add the symbols they already had to show numbers past 20. Using the same number, 453, let's understand how to write it in the Aztec numeral system. There are multiple ways to express 453, which I will explain later on. First, break up the number into expanded notation. We get 400 plus 50 plus 3. The number 400 can be represented by a feather with 15 barbs or a bundle of stems tied together. The number 50 can be written in many ways, such as 2 flags and a diamond, or 5 diamonds. For convenience purposes, I will be sticking to the least symbols needed to be drawn. Finally, the number 3 is represented by 3 dots. And there we have it, the number 453 in Aztec numeral notation. Comparing Mayan and Aztec numeral systems. With the side-by-side comparison, there are some visible similarities the Aztecs share with the Mayans, such as the symbols, dots, and bars for 1 and 5. Though there is no explicit Aztec math, it is believed that they were taught a Maya-derived math using the same additive concept, hence the vigesimal base 20 system. Not only do we know the history of the ancient Mayans and Aztecs, we can now visualize how mathematics played an important role of shaping their world.